If you're new to my channel, this is Dr. Sponza and I'm here to give you a lesson on statistics, and that's what I do in my YouTube channel, creating math lessons for students and teachers for their math classes. So for today, we're going to be working on statistics, specifically on how to answer probability involving continuous random variable, specifically targeting the uniformly distributed sample. So there are two distribution that we're using in continuous random variable. One is the uniform distribution, which resembles a rectangle, and the other one is the normal distribution, which resembles a bell-shaped curve. So in this particular problem, we're going to be working on probability of a uniformly distributed sample. So in this case, the problem is that the waiting times between a subway departure schedule and the arrival of passengers are uniformly distributed between 0 minutes up until 7 minutes. So we are going to be finding the probability that a randomly selected passenger has a waiting time that is greater than 5.25 minutes. So to be able to answer this probability question, you just need to make sure that you're understanding the concept of continuous random variable and a uniform distribution. So this is uniformly distributed, so that means our visual later on will resemble a rectangle. So our notation is P of greater than 5.25 minutes, which is basically telling us that we're working on the probability or finding the probability that the waiting time of this selected passenger is over 5.25 minutes. So our visual, we have the y-axis and the x-axis, and our horizontal axis will be our variable for time, and that would be from 0 minutes all the way to 7 minutes. And since this is a uniform distribution, each partition in our minutes will be equal. So what we're going to be working on is to find the height of our distribution, and to be able to do that, you will notice that our distribution is resembling a rectangle, just like what I've mentioned. And to be able to find the height, we're going to be using geometry to figure this out. So in geometry, if we have a rectangle, the area of a rectangle is equal to A equals length times width, and in this, or length times height in this particular rectangle. So our length is going to be from 0 to 7 minutes, and the height is what we're going to be looking for. So using algebra, we'll have 1, which is the area of our entire shaded region, because in statistics, the area of a probability distribution should always be equal to 100% or 1. That's why our area is automatically given in our uniform distribution problem. So 1 is equal to 7 times h, and to be able to have h by itself, we're going to divide both sides by 7. Now h is equal to 1 over 7, or in decimal form, 0.14. So that is why the height is 0.14. And now that we have all the ingredients that we need to answer P of greater than 5.25, we're just going to illustrate greater than 5.25 minutes in our rectangle. And to do that, so in our horizontal axis, just go to 5.25. So just rough estimate of 5 1/4. All the way to 7 minutes, because that is what the probability is asking us to complete. So the shaded region is 5.25 and 7, or between 5.25 and 7. And to be able to mathematically compute for that area under the region, we're simply subtracting 5.25 or 7 minus 5.25. And the formula for finding the probability of a continuous random variable like this, or a uniform distribution similar to this one, is the length of the shaded region multiplied by the height of the shaded region. And the length of the shaded region, as I have mentioned, is just going to be 7 minus 5.25. So that's what the shaded region is. And we're going to multiply it with the calculated height that we had, which is 0.14. And now we have 1.75 times 0.14, which is equal to 0.245. And that is basically the probability that we are looking for in this uniformly distributed problem. So therefore, the probability that a randomly selected passenger has a waiting time greater than 5.25 is about 24.5%. So this is how we answer problems involving uniform distribution of a continuous random variable, and different variation of this problem would be that area of the shaded region is at the left end of the rectangle, or at the right end of the rectangle, or in between your rectangle, or in the middle of your rectangle. So the process will still be the same. You just need to figure out a way on how to compute for the height and the area of your shaded region depending on the problem. This is Dr. Speranza, and this is my lesson on statistics. Bye!
Oo, kasi walang libre. Kami meron na ganyan din ako. Kani-kanilang first flip videos, at ito po yung first time.